Hey y'all, hopefully you guys are getting used to indefinite integrals at this point. Now you may be wondering, is there ever a time that I can get my hands on what the constant c is that we tack on at the end? And it turns out there are definitely cases where we can do that. The first case that we'll run into are initial value problems where we can actually figure out what c is and get our hands on a unique function that satisfies that property. So without further ado, let's get into it. Now recall that the whole idea about anti-differentiation is that if I give you a derivative, you can find an original function that when you derive that original function, you get the derivative. So let's consider the following question. Say that f prime of x is equal to 3x plus 2, and that f of 1 is equal to 3. Notice I'm talking about the original function here. What was f of x? Now remember that if I do something like this, the integral of f prime of x with respect to x, which we could write as just the integral of 3x plus 2. When I actually carry out this process, I'm going to land on something that when I derive it, I get back to just 3x plus 2. Carrying it out, we see by our power rule that we get 3/2 x squared, add 1 to the power, divide by the power you landed on, plus 2x plus c. Like I said, when you derive this, you get this back. And as far as last class goes, that's all we could really say. But we have new information. F of 1 was equal to -3. Now what does this tell us? It tells me that if I plug in 1 to this function, which is a candidate for f of x, 3/2 times 1 squared plus 2 times 1, and we still have the plus c, that thing should equal -3. But now hold up. From here we can do some solving out. For instance, 1 squared is just 1, so we get 3/2. 2 times 1 is just 2. 3/2 plus 2 plus c is equal to -3. We can definitely solve for c here. Subtracting over the 2, 3/2 plus c is equal to -5. And then last but not least, subtracting over the 3/2, c is equal to -5 minus 3/2, which is equal to -13/2. We all of a sudden get our hands on what c actually is. Therefore, I could actually give you what my original function was, since now I have what c was. So therefore, f of x had to have equaled 3/2 x squared plus 2x minus 13/2, plugging in for c. And this right here is actually our answer. So given just a little bit of information about the original function and initial value, what we could say is we could actually get the entire original function, the unique original function. This is the idea behind an initial value problem. Now let's try this example on for size. Find the particular solution that satisfies the differential equation f prime of x is equal to 20x cubed minus 4x and the initial condition f of 1 equals 3. Now, quick note, when we talk about a differential equation, that's just an equation involving derivatives, as you can see. When we talk about initial conditions, that's just some additional info about the original equation. And when we talk about a particular solution, that means the unique f that satisfies these two things. So we're just after f of x again. Well, in order to get an idea of what f of x might be, let's first off integrate. So, when we actually take this derivative, this integral, which is the integral of 20x cubed minus 4x with respect to x, what we should get by the power rule is 20 over 4x to the fourth minus 4 over 2x squared plus c. Add 1 to the power, divide by the power you landed on. This simplifies out to 5, make that a little neater, 5x to the 4th minus 2x squared plus c. Now we're not done. We can get a particular solution. This is a general solution, meaning c is anything. But since we have additional info, we can get our hands on what c is. Let's do that. Well, this info says if I plug in 1 for x, I get 3 as an answer. So, plug in 1 for x. 5 times 1 to the 4th minus 2 times 1 squared plus c, gotta still remember that, is equal to 3. Do some simplifying and solve for c, we'd find that 5 minus 2 plus c is equal to 3, or that 3 plus c is equal to 3, ultimately giving me that c must be 0. Now, since they're asking for a particular solution, they're not just saying, hey, get your hands on c and get your hands on the general. They're saying combine that into an actual function. So my answer is actually just this thing with c plugged in. Or f of x is equal to 5x to the 4th minus 2x squared plus 0, but we don't need to write that as always. And that'll do it for this initial value problem. Let's go ahead and end on one more example, this time with a little bit of a business feel. Find the cost function, the original cost function. Given the marginal cost, dc over dx is equal to the 4th root of x divided by 10 plus 10, when also given the fixed cost of $2,300. Now note the fixed cost is the cost when x equals 0, what you'd be paying regardless of how many units you produce. Well, since we're after an original function, the original cost function, and we're given the derivative, we need to climb back up the ladder via anti-differentiation, or integration if you will. So the first step in pursuit of the original cost function is to integrate the derivative. The integral of this guy, now I know it looks a little goofy with 2 dx's in there, would be the integral of just this function. 4th root of x over 10 plus 10, all with respect to x. Now remember, as far as calculus goes, we don't like that 4th root notation unless we're evaluating. So as a good first step, always change that to a fractional power. And in fact, I'm even going to write it as 1/10 times x to the 1/4 plus 10. Now, to actually carry out the anti-differentiation, remember that you add 1 to the power, so we get x to the 5/4 this time, and divide by the power you landed on. 1 divided by 5/4 is going to be 4/5. We still have that plus 10, so don't forget the plus 10x. And last but not least, never forget the plus c when it's an indefinite integral. Alright, well now we just got to simplify out. Turns out that 4/5 times 1 over 10 would be 4 over 50, or simplified out, 2 over 25. So our general solution, meaning the one without c figured out, is 2 over 25 times x to the 5/4 plus 10x plus c. But since now we have this bit of information, we can go ahead and figure out what c is. This bit of information encoded in says when I plug in 0 for x, I get $2,300. So just do that. Plug in 0 for x. 2 over 25 times 0 to the 5/4 plus 10 times 0 plus c. And that thing is equal to $2,300. Now you might have noticed, hey, we're just going to get that c, since both of these guys turn to 0, is equal to $2,300. And you'd be absolutely correct. Therefore, my final answer, if you don't mind, I'll write it up here, is that c of x Since we're talking a cost function, I'll call it c, and since it's named dc, or c right here, we got to call it c, will be 2 over 25 x to the 5/4 plus 10x plus $2,300. And that is my actual answer. Now maybe just some intuition right here to end the problem. We notice that, hey, a fixed cost of $2,300, that better be your y-intercept. If that's your value when x equals 0, it kind of makes sense that $2,300 just ends up equaling c. However, it's always safer to go ahead and carry out this process of plug in what your x is, set it equal to what your y is, and just see out the algebra. But the intuition also makes sense. Hey y'all, thanks for tuning in today. Now as a quick recap, what we discussed were initial value problems. In summary, what this said is given a derivative and some info about the original function, meaning a point on its graph, turns out we can actually find out what that c actually was and get our hands on the particular solution, the unique solution of what f of x actually was. In order to do this, what you should do is integrate first. Get your hands on the general solution, the thing with the plus c, and then use your point, plugging in for x and setting equal to y, use that point to solve out for c. Last but not least, if they're asking for the particular solution, note that your answer will actually be the function and not what c was. So list out the entire function as your answer. So that's kind of our first little glimpse at integrals. Next time we'll be getting into how to solve more classes of integrals. We'll be adding on rules that will allow us to solve more things. So without further ado, go ahead and try out your homework, and thanks for watching.